So this lecture is about columns. What we are going to do in this lecture is we are first of all going to talk about the how the columns behave, where are the columns used, what should be the spacing of the columns, and what are the types of loads that act on the columns. These all things we'll be discussing in this lecture. In the subsequent lectures, we then will have to go into the analysis and design of how that is done. You already know how the analysis is done for columns and what are the moments and the actual forces that are determined for the columns. Now, in this course, we will be going for the design of the reinforced concrete columns. Now, first, we need to focus on what are columns, where are they used. So, first of all, columns and their design. How do columns behave? Thing. Then, where and how are columns placed? Second thing, what are the types of columns? Then, what are the loads on columns? What are the loads on columns? So, I I was talking about that columns and their design, which we are focusing on. First, we'll be talking about how do columns behave. Now, you have a column set up like this, and over a column, you might have a beam only on one side. We can say this is a beam on one side. Then you have this as the column. Now, this column, the loads that would be transferred on this column would be transferred from the beam onto the column, but they will not be transferred. There are two modes of transference of the load. First is, if this is the section of the column, the cross section of this column, you will have two axes, x-axis and y-axis for the cross section of this column. Now, if the loads are coming through, passing through the center, the loads are transferred through the center. That means through this point. Through this central point, then the load is concentric. Then the load is concentric. Now, if the loads are not passing through center, but they are acting at a distance from the center of the cross section. जब हम क्रॉस सेक्शन को देख रहे हैं, ऊपर से देख रहे हैं towards the plan of the column, then for example, if it's somewhat like this, passing at a distance from the center, the load is being transferred, the center of the load, the center of transference of the load is not at the center of the column, then the loads are transferred eccentrically. So that's concentric and this is eccentric. Now, it could be eccentric about one axis. For example, if this is x-axis and this is y-axis, it could be eccentric. Right now, it's eccentric from the y-axis. Now, or about x-axis, it's eccentric right now. Now, at the same time, it could be eccentric about both axes. Now, if it's somewhere here, eccentric about both axes. This is, so it's biaxial eccentricity, and this is uniaxial eccentricity. Now, most of the times, we find uniaxial eccentricity rather than biaxial eccentricity. Now, that further depends upon how many beams are acting over the column. Right now, I showed you an example here. In this case, you have this beam. It's on one side of the column. Now, all the loads that will be transferred to the column, they will be transferred unsymmetrically. And that would mean the loads would be moreover transferred eccentrically. And that too, the eccentricity in this case would be uniaxial. So we can say that this column, right now I'm showing you in the figure, is under uniaxial eccentricity because of unsymmetry of the transference of the loads. Further, there are many more cases where there could be unsymmetry of transference of the loads, even though the beams are placed symmetrically. For example, in this case, there are beams on both sides of the column. This is the column, and these are the beams. And the beam is placed symmetrically. मतलब जितना इस साइड से है राइट साइड से उतना ही लेफ्ट साइड से बीम उतनी डिस्टेंस तक है of same there are more chances of this being under concentric loading. However, if the length on either of the two sides increases, then it becomes, for example, on this side the length is increasing, then it is becoming eccentric. The nature of the load will be such that it will become eccentric. Moreover, even if that's not happening, if the lengths are same, if the cross-sectional dimensions are different on the two sides, for example, on this side you have column with beam which is of lesser depth as compared to that on the other side. So the moment of inertia on one side will be more and on the other side will be less. So it's again unsymmetrically placed. So the moment of inertia I1 here would be greater than I2. Thereby, you would have eccentric loading on the, now all these types are uniaxial eccentricity. This is uniaxial, this is uniaxial eccentricity acting on the columns. Then the third thing, you might have this as the situation where it's the beam is placed concentrically symmetrically over the column, but there are more loads on this side. For example, the loads on this side are more, uh, say W1, and the loads on this side are less, W2. So the nature of transference of loads onto the column, जो column पे load अब आएगा, that load would be more from W1. So what would naturally happen? It would tend to and shift towards this side, the column. So there would be an eccentricity towards the, जहां से ज्यादा load आ रहा है तो वहीं की ओर there would be a shift in the transference of the load. So eccentricity depends upon three unsymmetries, that is, uh, the whether beams are placed on both the sides, whether the length of the beams on both sides are same, then whether the moment of inertia, that's the second one, is same on both the sides, and the third thing is whether you have the load acting, similar loads acting on both the sides. So these are uniaxial eccentricities. Now, if in a plan, this is a plan of anything, a hall or something like that, and you have a column here, for example, it's placed at the center of this whole, and then you have beams connecting now. All these beams would then be again connected to the walls or to the columns here. So there would be columns at the edge support. There could be further beams at throughout the length of perimeter length of this hall. Now, because this column is placed at the center, if there is a continuous slab over this hole, uh, then and of the similar thickness, and these beams are all of equal length. So the load is placed, then the load from the slab is coming symmetrically, as well as the beams are placed symmetrically. And if the beams have same depth and dimensions, then the load on this column is concentric. However, on if this column at the center is not placed symmetrically, it's shifted to some other direction, and then obviously it would come under unsymmetrical loads as well as unsymmetrical lengths. Thereby, what we can say that it could undergo both in both directions. For example, now if in the same scenario you have a column placed somewhere here and you have beams acting like this, now the beams are of different lengths. In this direction, the beams are of different length. In this direction, the beams are of different length. So this column is under biaxial eccentricity. If you now make the cross section of this column. Now, what do you think? Where, on which side of this, if it's in the same direction, ये अगर x है, if this is x direction and this is y direction, now this is y, this is x direction. Now, on which side of this xy do you think will the center of the load or the will act now? Yes. Anyone? Sahil Yusuf. Sahil. $73. Akid. Akid.
Yes, sir. Actually, मैं बाहर हूँ अभी. I'm driving, so.
48. Babar. 48. Babar. Ji, Babar. Now, those who don't respond, then I think I should mark them absent. If you're not participating in the class, 27, Mohsen.
Yes, sir.
हाँ जी, कहाँ, किस साइड से, on which side of this xy towards, uh, let me give you options. Will it be here? Will it be here? Here or here?
Sir, fourth वाले में, sir.
Which one? This one?
Yes, sir.
Now somebody else, roll number 4, Shraib.
Yes, sir.
Which side do you think? If this is, say, 1, this is 2, ये session close होने वाला है, you will all rejoin if. हाँ जी, Shraib, which side?
The third.